In this section, I want to talk more about trigonometric identities and what those are and what those are not. And it really comes down to whether something is conditional. So I'm going to skip down to here. Remember that a conditional equation is an equation that is true for only some of the values in its domain. As an example, the conditional equation sine of x equals 0 is only true for x equals n pi, where n is an integer. Okay, when you find these values, you are solving the equation. So you are saying that this is true only for these values, but for everything else, it's not true. This is true, sine of x equals 0. This is only true for x equals, 1 pi or 2 pi or 3 pi or n pi. But for anything else that doesn't fall in kind of that format, it's not true. Whereas an identity is true for all values of x. So when I look at something like this, sine squared of x equals 1 minus cosine squared of x, this is true for all values of x. No matter what I plug in for x here, plugging it in for x here for sine squared of x, as well as over on the right side, 1 minus cosine squared of x, no matter what I plug in for x, this is going to be true. And so that's the difference between what is a conditional equation and what is an identity. So then how can I verify whether some equation that I come across is an identity or not? Here are some guidelines. 1, you're going to have two sides of an equation. You should begin working on only one side at a time, and often it's better to work with the more complicated side. 2, look for opportunities to factor an expression, add fractions, square a binomial, create a monomial denominator. There's lots of different tools at your disposal, and we had talked about how as we get further and further along our math journey, you're going to learn a lot more tools to put in your toolbox, and you're going to come across problems where you just kind of have to open up that toolbox and figure out what do I need? What do I need in order to solve the problem at hand? 3, look for opportunities to use the fundamental identities. So that is these identities here. A lot of times we can use the reciprocal identities, the quotient identities, and the Pythagorean identities. So look for opportunities to use these. 4, when the preceding guidelines do not help, so when 1, 2, and 3 don't seem to work out, try converting everything to sines and cosines. And 5, always try something, because when you try something and it doesn't work out, at least you've learned something from that, and you can try something else. So let's try to verify that this is an identity here. Secant squared of theta minus 1 over secant squared of theta is equal to sine squared of theta. So I look at this, and based on my guidelines, I'm going to work with one side at a time, and we're going to try the more complicated side. So to me, that's certainly going to be the left side here. That looks more complicated than just sine squared of theta. What I'm going to try and do is I'm going to use primarily my fundamental identities here to try and manipulate the left side and simplify it down to match what the right side is. Can I get the left side to be sine squared of theta? All right, let's start. I've got secant squared of theta and minus 1 in the numerator. One of the things that I look for are if I'm working with trig functions that are squared. Am I adding two of these together? Am I subtracting a 1, adding a 1 somewhere? Typically, that tells me to look at my Pythagorean identities. So I'm going to bring over my fundamental identities. Okay, like so. And I'm going to look for something with secant squared in it. Okay, so secant squared, right here, I have a secant squared, and I've got a 1 in there as well. 1 plus tangent squared equals secant squared. Can I use this in some way? Because I've got both of those parts there. So let's just write that down. 1 plus tangent squared equals secant squared. So 1 plus tangent squared of theta is equal to secant squared of theta. Now I've got secant squared of theta minus 1 up here. So let's just subtract 1 from both sides. So tangent squared of theta is equal to secant squared of theta minus 1. Okay, so I don't know if this helps me yet, but up here is secant squared of theta minus 1. I can change that to tangent squared. So let's do that. This will read now tangent squared of theta over secant squared on the bottom still. Okay. Let's try to convert things to sines and cosines. Just like up here, I've had 4. Okay, try converting everything to sines and cosines. So tangent is sine over cosine, so tangent squared would be sine squared over cosine squared. So this would be sine squared of theta over cosine squared of theta all over secant. The reciprocal of secant is cosine. Okay, so what can I do here? Secant squared is the same as 1 over cosine, so I can say 1 over cosine squared here. Okay, now I've got a fraction over a fraction, so I can multiply, flip this upside down, I can multiply by the reciprocal, cosine squared of theta over 1, and then same thing up here. Down here, everything will divide out. And up here, I'll have sine squared times cosine squared, and then over cosine squared times 1. Cosine squareds here can divide out. So this leaves me with sine squared of theta. So now I've changed the left side here from secant squared of theta minus 1 over secant squared of theta to match the right side. Sine squared of theta equals sine squared of theta. This is an identity. Okay, hopefully this helps out. We'll work on these more in class.